Hi everyone. Today we're going to try out a simple question here where you're given two strings and you're asked to check their anagrams of each other. Now, so I've got four strings here. Let's compare S1, S2, and then S3, S4. Now, if you eyeball here, if you spend a little bit of time, you'll notice that S1 and S2, these are anagrams of each other. S3 and S4, these are not anagrams of each other. Now, one of the approaches that come to mind for determining if these are anagrams or not is by sorting. Now, if you think about the time complexity and the space complexity involved, let's tabulate this here. So what's going to happen is for sorting, you would typically see B of n log n asymptotic complexity, and then depending on the type of the sorting algorithm you use, if you do in-place sorting, you can get away with the constant space, or if you're using things such as merge sort, you even need a big of n additional space, where n is the size of the input. The question is there a way by which you can solve the problem by using linear time and constant additional space regardless of the size of the input? So if you think some more, if when you're saying big of n, where n is the size of the input, it would mean that you are accessing each of the characters in the input string in constant time. So to do that, the best data structure that you can think about is use arrays. And we'll describe a little bit more in detail as to how you could leverage arrays to get to achieve this combo of complexities for time and space. Now, there are a few things that you need to keep in mind when you think about using arrays, which is how big should the array be? Now, again, just to reiterate the use of the arrays here, we're essentially using the array to keep track of the counts of the number of occurrences of a character in a string. And once you so you do that for the first string, say in this case you do it for S1, you would for each of the characters you figure out how many times they occur, and then use that data structure to do a linear scan on S2 to see if the characters, the number of occurrences of the characters in S2 match with S1. Obviously, this is all done assuming that the length of S1 and S2 are the same. So now, if you going back to this question, how big should the array be? It depends on the character set. So if you think it's all lowercase English alphabets, then you can get away with the array size of 26. If you think it is characters can be not just lowercase alphabets, it can be any ASCII character, then you have to go with a size of 255. So in this example, we'll go with a size of 255. So here's a simple algorithm. So returning true or false, and I'll define a function called anagrams. Takes in two inputs. You got string S1 and string S2. I'm going to define an integer array. I call it histogram, and I'm going to set the size to 255, and I'm also going to have a set two variables. I might just need one variable, but let's do two variables for now. The char count 1, which is s1 dot length, and I'll have int character count 2, which is s2 dot length. Now the first obvious check is to see if character count 1, if that's not equal to character count 2, I would just return a false. Don't have to go any further. This condition is not, if this condition is met. Now, the next step is to go ahead and populate this histogram. So I would iterate through the input string, the first input string. I would just do an increment of the value indexed at s1 dot char at I. Okay, so this is what I would do. So by the end of this loop, I would have so to be so basically at the end of this loop, I would have populated the histogram now by scanning through the input S1. Now the next step is to scan through S2 and validate if the number of occurrences of the characters in S2 tally up with that in S1. So the way I would do that is, again, have another for loop for int I equals 0, I less than char count 2, or it can be just char count 1 plus I. I'm going to do an if check here. If histogram of s2 dot char at I, if that is equal to 0, I'm going to return false. Now the reason being that if I had seen this character in this loop, I would have seen a non-zero value, at least a 1. In this case it's a 0, which means I haven't seen this character, at position I in S2 in this for loop. So that's why I'm returning a false, which means there's a mismatch. Now if it is non-zero, I would go ahead and do minus histogram of s2 dot char at I. Now the other way this can equality would be hit is if you have excess characters in S2 for a given character that also exists in S1. So for example, if you have 3 A's in S2 and only 2 A's in S1, then you would actually be hitting this equality, because you'll be trying to decrement that value at this the data structure at this key more times than what was initially populated when traversing through S1. Now if all of these conditions are met, then you would actually return true. And so essentially at the end of when you hit this line here, you've actually, if these are truly if S1 and S2 are truly anagrams of each other, you would have actually decremented the frequencies in this histogram for all characters in S1 down to zeros, and that's when you would hit this. Else you would actually hit this line here if there is a mismatch, and you return a false. So if you do a quick analysis here, this is counts in space, because regardless of the size of the input, you are always reserving an integer array of size 255. Let me make that a correction here. It's actually 256 because you have including nulls. So you would have the null character has an ASCII of 0. So you would take 256 positions. So you'd have an array of size 256. So you have big O1 space, and then each of these for loops. This is big O of n, time, and it's the same here. So overall, you meet this objective, and that's your answer. Thanks, everybody.